In this video, I'm going to talk about some mathematical properties that are really important to know to help you to understand how to solve quadratic equations, but also how to solve linear equations as well. And you can use these properties in this unit, and you can continue to use these properties and your knowledge of these properties throughout your entire mathematical career. So the first property is the commutative property. When you hear commutative, you might think of the word commute, which means move. And that's kind of what this property means. This property tells you that order does not matter when you multiply and add. For example, I might say a plus b, or I can also say b plus a. I can move around the expression if I'm adding or multiplying, and the value will not change. Here are some examples, right? We know that 8 plus 4 is the same as 4 plus 8. Or 9 times y is the same as y times 9. You already understand the meaning behind this. You might just not have remembered the actual property itself, the name of the actual property itself. Where do you see this when solving equations? Well, you might rewrite 4 plus 2x to be 2x plus 4, if that's the way you prefer to order your equation when solving it, and you're able to do this because of the commutative property. The associative property tells us that grouping does not matter when multiplying and adding. When you hear the word associate, you might think of who you hang out with. And that's kind of what this property alludes to. The parentheses show who the variables are associating with, and you can switch those parentheses around and group them differently if you're adding or multiplying. Here are some examples. I could group 5 and 2 and then add 8, or I can group 2 and 8 first and then add 5. And in this one also only works for multiplication and addition. These two properties do not work for subtraction or division. Where do you see this? Well, if you're combining like terms, you might say to yourself, if you saw 2x plus 3y in parentheses, well, they can't be grouped. But I know that I can group 3y and 2y. So I'm going to regroup those together using the associative property. I change the grouping, but not the expression. You can multiply a term on the outside of parentheses by each term on the inside of parentheses to find a product using the distributive property. Here's an example. I could say 3 groups of 4 plus 5, and I can multiply 3 groups of 4 and then do 3 groups of 5. And I can still get the same answer. You probably recognize this expression a lot. 2 times x minus 2 is really just 2x minus 4. Another way to write it, using the distributive property. You see this in solving equations often when you're distributing the 2 to each term inside the parentheses. Another property is additive inverse. Additive inverse tells us that a number added, additive, to its opposite, inverse, has a sum of 0. This is something that you probably do all the time, make 0 pairs, and you don't realize this is called additive inverse. Here are a bunch of examples. These cancel out. It's basically thinking of canceling out to make 0. Where do you see this? Well, when we solve equations, we might subtract 4 on both sides to make that 4 into a 0. Really, I'm also just thinking of it as adding negative 4, finding the additive inverse for 4 to make a 0 so I can begin to isolate x. We also have a multiplicative inverse. So what is the way to cancel out for multiplication? Well, a lot of you think of division, but the multiplicative inverse is multiplying a number by its reciprocal because that will make a 1. If I do a times 1 over a, that will equal 1. Here's some examples. 1/2 times 2, 1/5 times 5, 3/4 times 4/3. This is a really good skill to have, this is a really good property to have an understanding of, especially when you're solving equations with fractions, because you can cancel out 3/4 by multiplying it by 4/3. Where do you see this? Well, I can divide both sides here by 2. My other option is to use the multiplicative inverse and to do 1/2 times 2 and make a 1x, and do the same thing on the other side and make a 3 to help me solve this equation and get x by itself by turning the 2 into a 1. Okay? Now we're going to talk about the properties of equality. There are 4 properties of equality, one for each operation, and they all say the same thing. Whatever is done to one side must be done to the other side. And then the equation will stay equal. That's all about keeping equations balanced. Here's an example. I can multiply both sides by 2, and I'm going to have the same value. Where do you see this? Well, right here. Again, I can use property of equality to say I can multiply both sides by 1/2, and both sides of the equation are still equal. The equation is still true. Division property of equality. Well, I can divide both sides by the same number, and the equation will say true. And you can see that here when we divide both sides by 2, and the equation is still true. Both sides are still equal. We use the properties of equality throughout solving equations. Addition property of equality, adding the same thing to both sides, and it will keep the equation true. And you can see that here when I'm adding 4 to both sides, and I'm getting 14 on 0 here. I'm just moving it over. I'm using the property of equality to keep it balanced. You can really think of properties of equality as a scale, keeping that equation balanced. And then the subtraction property of equality is about subtracting the same number from both sides, and keeping the equation true that way. Additive identity. So additive identity is all about how can I keep the identity of the number the same. So for adding, I can add 0 to any number and it stays the same. It has the same identity. And right here you can see that. When I did 4 minus 4 and I had 0, I don't need to write that. I could just write 2x equals 6 because the additive identity tells me that 2x plus 0 is just 2x. Doesn't do anything to it. The identity stays the same. Multiplicative identity now is saying, well, what do I multiply by to keep the identity the same? And that's a 1. So 1 times any number, that is still the same number. And we see that here, right? We solve this equation. And we're going to see that, oh, well, we could write 1x equals 3. Why do we need to do that? Because we know 1x is really just x. Multiplicative identity. And now we have the zero product property, which is really important for solving quadratic equations. And basically it says if the product of 2 factors is 0, then one of the factors must be 0. We know that, right? If we tell you 5 times x equals 0, you all know x has to be 0. And here's another example. Now we get into these quadratic equations, ones which get a little bit trickier, but basically this is just telling me x plus 3 is 0 or x minus 7 is 0. One or the other has to be 0 for the equation to equal 0. And again, we see that here using the zero product property in algebra to solve quadratic equations. Okay. And so in summary, you can having a clear understanding of these properties helps you to justify the steps you're taking when solving equations, and also helps you to understand if a step or a strategy you want to use actually is mathematically accurate if you can base it on one of the properties. So please try to remember and study these properties so that you can use them throughout math, throughout your education.